We begin chapter 3.1, Measures of Center. So in this chapter, we're going to find the measures of centers, which are going to be called statistics from the sample, for particular variable data distributions. Please review the pages 91 through 100 using our worksheets for chapter 3.1. The objective of this chapter is to compute the mean of a data set and also to compute the median and compare the properties of the mean and the median. And finally, we're going to find the mode of a data set and approximate the mean and the median with grouped data. So we're going to find the mean for a quantitative variable. It is one of the center measures, and the mean is really the arithmetic average. So the mean is the sum of the values of the variable divided by the number of observations of the data set. So in this example, we have 5 numbers in the data set. They go from 68 to 92. If we add those 5 numbers together and we divide them by 5, we will get the mean value of 81.2. Both the population and the sample have means. The population mean is considered a parameter, and the sample mean is a statistic. Typically, we can't calculate the population mean. If we had all the information of the population mean, there's a formula for calculating that mean value, which we call mu for the population. It is the sum of all of the values for x added together, obviously, divided by the total number of individuals in the population. So this will be your first symbol that you may not know. It is the summation symbol. It means summing up all the numbers from the first observation to the very last observation. And again, typically we cannot calculate the population mean value. So in general, we go to the sample and we calculate the sample mean, and the sample mean is just all of the values for x in the sample added together, divided by the sample size, which is n. A second measure of a center for the data set is called the median. So the first step in finding the median is to sort the data set from the smallest value to the largest value. So from that sorted data set, you find the middle observation or the middle value of that data set. Sometimes if the data set is even number of observations, then you have to take the 2 middle observations and add them together and divide by 2. If it's odd, you just have to find the middle observation. Another way of finding the median, which we will find later on, is there is what's called the median location. The median location is found by taking the sample size, adding 1 to it, and dividing it by 2. If the number is even, you just count from the beginning value of the sorted data set to the end. And if it is a decimal point, then you take the average of the two middle numbers. So for example, we have a problem here. 8 patients undergo a new surgical procedure, and the number of days spent in recovery for each is as follows. Find the mean and the median number of the days in recovery. So here's our data set. It starts out at 20, 15, 12, 27, 13, 19, 13, and 21. To find the mean, we add those numbers up and we divide by 8, and the mean we find to be is 17.5 days of recovery. To find the median, we sort the data set, so the smallest value was 12 and the largest value was 27, so we sorted it in order. And then we realized that the two middle numbers was 15 and 19. It was an even number since n is 8. So the two middle numbers are 15 and 19. We divide that by 2 and we get 17. Notice here that the median is smaller than the mean. So typically when we find the mean and the median for a data set, we want to compare the two values to see if there are any extreme values that may be affecting the calculations for the mean value. So if the median is at the same location as the mean, the distribution is considered symmetrical. So here we have a symmetrical distribution, which is our bell-shaped curve, and sometimes we call it the normal curve. But it's also possible that our symmetric distribution is more uniform, where it's just kind of like a straight line. This is called a uniform distribution, and that happens periodically, and it's also symmetrical. If the median is less than the mean, then the center is being pulled to the right. So here is the median, and here is the mean, and you can see that the mean is being pulled to the right. We call that skewed right. Skewed right. If the median is greater than the mean, then the center is being pulled left. So in this particular case, the median is over here, and the mean is to the left of it, and so the center is being pulled to the left, and in this case it is skewed left. Another important part of the distribution may be the most frequent value in the distribution. It's not always calculated, but it does have an effect on the statistics. So again, the mode is the most frequent value in the data set. And basically, you can find the mode both for quantitative and qualitative data sets, whereas for the mean and the median you cannot. So the most frequent observation is considered the mode. The shape of the distribution can be determined sometimes from the mode, and we saw in the previous chapter the difference between unimodal and multimodal and even bimodal distributions. So in our example of the 8 patients that undergo the surgical procedures to find the number of days of recovery, for the 8 days we see that there are 2 values that are the same. These are the most frequent values. So the mode in this case, it's unimodal, and the mode is 13 days. So typically, we don't have the data set if we're looking at a research report or if we're looking at financial data from a newspaper. We typically don't have the actual data. So sometimes we want to estimate the mean and the median from what we call grouped data. And the group data is our frequency tables that we've seen before. So we will go into an example in just a second. So the first step in our using group data and finding group data is to compute a midpoint of each class. So we're going to show you how to calculate the midpoint. The midpoint is taking the lower values of each class, the first class and the second class, adding them together and dividing by 2. So in this case, if you look at our example, you take the lower 2 values of the first 2, you add them together, 50 plus 0, if we're looking at our example, and you divide it by 2 and you get 25. So in the next step, for each class, you multiply the class midpoint by the class frequency. So we're going to take the midpoint value and multiply it by the frequency to get a value which is the multiplication of the midpoint times the frequency. And in our first line of example, we multiplied 25 times 10 and we got 250. Then step 3 is to add all of the column that we've just done with the products. In other words, we add the 250 to the 150 to the 1625 all the way down, and we get to 6850. And finally, we divide the sum obtained by the multiplication products, adding those all up, and we divide it by our frequency column, sum, which is 50. So in the example of the number of text messages sent by phone, a sample of 50 high school students, and then the frequency of the number of messages sent. So the class size, or the classes, go from 0 to 49, 50 to 99, and so forth, all the way down to 250 to 299. Those are our class intervals. Right? And then from the class intervals, we counted, well, someone counted the frequency of each of those text messages between those two values. And we got the frequencies. And then we added the frequencies up, and it should come out to be 50 students. And it does. Then we calculated the midpoint. And the midpoint, as we've said before, is we take the lower values of the class intervals to find the midpoint. So in the first case, we took 50 plus 0, which is 50, divided by 2 is 25, so that's the first one. The second one is 50 plus 100, which is 150, and we divided by 2 and we got 75, and so on. So all the way down, and then you say, well, how did you get 275? Well, the next number up will be 300. So we took 300, we added it to 250, and we divided by 2, and we got 275. So once we have the midpoints, then we can do the multiplication of the frequency times the midpoints to get the last column. And here in the last column we had 250, 150, and so forth, all the way down. And when we sum that up, we get 6850. So the mean, to calculate the mean value of texts, we took 6850, we divided by 50, and we got 137. So that's the mean value. To find the median location, we take the sample size, in this case the frequency sum, right? So the median location, right, is equal to, in this case, 50 plus 1 divided by 2, which is 25.5. So to find the median, we count on the frequency side, right, the frequency side all the way down until we get to 25, and that brings us approximately there, right? When we count down, we get, 10, 15, 15 plus 13 is 28. So if we count it all the way down, 25.5 has to be in this cell. So our midpoint of 125 is our median. So our median in this case is 125. So that's how we work with grouped data. And in this case, guess what? The mean is larger than the median, so in some sense we have kind of a skewed right distribution for our frequency. Well, that concludes chapter 3.1.